Hello, this is Fundamental of Programming course CO1027. In this session, we are going to talk about pointer. Well, pointer is a very essential concept for every language. However, depends on the level of the language you are using. They may try to hide the concept of pointer. Okay, and for some language they try to change this concept into some other easier to interpret concept. Okay, for example, let me say if you're working on Java, you don't have pointer but you have another concept called reference, and reference is pretty much similar to pointer. Okay, and pointer is a very powerful tool for you to program, right? You can make a lot of use from pointer as you see in this course. I will try to explain as simple as possible about pointer, and hopefully you may try to make some questions during the lecture and take a note when you go to the class. I can explain more about pointer for you because that is interesting. Okay, so let's say, what is pointer? Well, I don't get why people are so scared of pointer because it's so easy to understand. Saying about pointer like a way to know the location of your variables. Okay, in short, it's just an address. Okay, so when you say about pointer, you are talking about the address of some memory slot in the memory, right? And here is a very simple imaginations of what is happening in your programs. When you declare a variable, for example the count variable as integer count, then you see that on the memory you have one slot 4 by 4 your variable. Okay, and if you declare a pointer count ptr and let it point to count, then depends on the location of count, the value inside pointer will contain that. Let's say count stay at the address 0xf0, then that value will be put inside this memory slot, which is 0xf0. Okay, so think about pointer as just a memory slot, but instead of contain the value, it contain the address of another memory slot. Okay, and that's easy, right? We don't have to think it too hard. Now, in order to declare a pointer, you can do it this way. Declare it with the data type, then followed by a star, and then the variable name, the pointer name. Okay, for example, you may say a as a pointer of integer. Now I'm trying to tell you how to read this statement. Okay, you read from the right to the left. Now you say a is an pointer of integer. You can read it this way. A is a pointer of integer. Okay, so reading like that is easy for you, right? But there's another thing that I would like to keep a note here. Let's say you declare integer pointer a and b, then you may think that a and b are pointers of integer. No, it's not. A is a pointer of integer, however b is an integer. Okay, so this kind of annoying because sometimes you may want to declare several pointer, so you may say integer pointer a and pointer b. Okay, so this one say a is a pointer of integer and b is also a pointer of integer. Okay, I know the first time you see this is not easy, but well, you have to take on this concept, right? So sometimes it is more convenient if you declare a type of pointer, and so it gives you easier way to declare variable. For example, here you can use the type define in order to define a pointer of integer as this one, integer pointer. So I told you this one is the alias, right? This alias can help you to declare several pointer variable at the same times. Easy, right? It's also clear for a lot of programmers. So sometimes people tend to define the pointer type explicitly, so everyone aware of that pointer. Okay. Now, in order to use the pointer, what you can do? Well, there are two things you have to know. When you use pointer, it's relate to the address of memory, right? So there is the operator n. This one will let you take the address of some variable. Remember, this n is the bitwise operator, but only if you have two operands, right? When you have only one operand here, it is understood as the address of that memory slot. Okay. Now you can take the address of memory and set it to the pointer. Alright, that's easy. You can also access the memory where the pointer point to, right? In that case, you use this star again. This star is called the referencing operator. The referencing operator, and it lets you to access the memory slot where IP point to, right? So you can read like this one. You read that memory slot value. You can also write some value into that memory slot. Okay, I think that's clear. Now, when you work with pointer quite often, you are going to use to know about a null pointer. So null pointer is nothing but 0. Okay, this is because when you declare a pointer, the address is unknown, and if you say you do some operation on an unknown address, it's very dangerous. You may damage your programs. You may even crash the whole program just because you want to read or write to that address. So it is better if you initialize the value for your pointer as null, because at the moment you declare, you may not want to use it, so you just declare it as null. In that case, then well, you can use this null pointer, null constant in order to declare that special value for the pointer. It is equivalent to this one, null ptr. This one is another keyword that represents the null constant. Okay, it is nothing but 0. Right. You can also compare a pointer to null, because sometimes you want to check if that pointer is valid or not. Okay, either you reach the empty branch or not. You can use this check, or sometimes you can treat that value of the pointer as a boolean value too. Okay, so this means if the pointer is null, then I will do something, right? Easy? Yep. Okay, now what I want to tell you is a lot of different concepts here. The first thing is a pointer to a data. Okay, now by default I will ignore the non-constant here, because it may confuse a lot of people. So when I say constant, I will state it like this one. Otherwise I just ignore this one by default. Okay, So you see, the first case is you declare a pointer that point to data. For example, I have integer pointer p. Well, this is read as p is a pointer to integer. So this pointer can be changed to any other memory address. It's fine, okay? And the memory where p point to can be read and write at the same time, okay? For the second case, what you have is, for the second case, you have a pointer to a constant data. So it goes like const integer pointer p. This read as p is a pointer of const integer. So what it means? Now p can point to any memory slot. Okay, p can point to any memory slot, but it can only read the data from that memory because that memory is constant integer. So you can only read, you cannot write the data into that memory slot. Okay. For the third case is a constant pointer to data. Let's say I have the following statement: integer, okay, pointer, oh no, what should I say? It is supposed to be, yeah, a const pointer. So it goes like this: const p. Just say p is a constant pointer of integer. So this declaration actually wrong because when you say p is a constant, it means you have to assign it to some value, otherwise you get the compiling error. Okay, so this means the address of p, the address where p point to cannot be changed. I cannot change p to another memory slot, no, but I can either read and write some data on that memory. Alright, the last case you may guess, right, is a const integer. Const. This one's like saying I have p as a constant pointer that point to a memory slot of const integer. So this one point to a memory slot and cannot be changed, and then that memory slot can only be read, not write. Okay, so I guess if I have more time to demonstrate for you on the class, then we may have see this concept clearer. So here I have some slide for you just to take a note and think about what you can do with all kind of pointer here. Okay, so the first case is the normal pointer, point to the data. Okay, full control. The second one, you restrict the permission of your pointer. Now it can only be used to read the data, not writing data. The third case is a pointer which is a const, so you cannot change the address of that pointer, right? The last case is a constant pointer, okay, point to a constant data. Okay, this one is supposed to be easy. And well, when you work with pointer, you can use some operations on pointer, including the increment, decrement, plus and minus. Okay, those are essential, so you can use it around your programs. Now the only thing I want to note here is you have to think about the value of your pointer. Okay, let's say you have an array of data. Let's say that array of integer. Okay, and for each memory slot you have 4 bytes. Okay, so I have here integer pointer point to this one. Now if the first address of P is 100, for example, then when you say ptr plus plus, it means you increase the value of P, then P point to this location. If that is the case, then now ptr will equal to 104, not 101. Okay, so remember this increment is actually increase the address of your memory by a unit of the data type. If you have a pointer of characters, it should be 101, but if it is a pointer of integer, it should be 104. Okay, now same thing apply for plus and minus on some other integer. Okay, you must multiply the sign of your data with this number. Alright, so I think that's simple, right? Now speaking of pointer, you can use pointer combined with some other operator, including the referencing operators here. So this one read I want to take the value at the location where P point to, but after this I want to increase the address of P by 1 unit. Okay, the second say I want to access the memory next to P, but after that I also increase P by 1 unit. Okay, this one say I want to increase the value of the memory where P point to. Okay, and the last say I want to increase the value of memory where P point to, but again this is the prefix operation and the second one is postfix operation. Remember sometimes you are not sure about the sequence of executions because some operators has a higher priority than the other operators. So the principle of the compiler will be execute the operators that have a higher priority. So in this case, this one has a higher priority. It will be executed first before using the reference operators. So sometimes if you don't feel uncomfortable when you write the code like this one, please use the bracket because it's safer way to write the code. You know exactly what you want to compute. Okay, now when it comes to array, there is a relevance. Okay, when you declare an array like this, it means you have array and you have var. Var is actually a pointer, but that pointer cannot change the address. In other words, think about var as integer const pointer. Okay, so you cannot assign var to any other address. However, you can set the address of var pointer to ptr. It's easy. This one is invalid, of course, because var is a constant pointer. Okay, so if I come back to this slide and yeah, it's like this one. Okay, ptr is a constant pointer to the data. Okay, so that's how it works, right? So array is similar to pointer, pretty much is a pointer, but in the initialization step, everything is fixed at the beginning. All right. I provide some example here so you can check out at home, and feel free to take note, and I will discuss more with you on class when you have the questions. Otherwise, I'm not going to explain. Okay, it's a little bit complicated. Now sometimes you want a pointer too. Don't think it something complicated. Just try to visualize your variables. So here I have the variables that actually contain a value here inside that memory. I have a pointer that point to the variable here. So PTR will take the address of var here, right? And well, you may have another pointer. Instead of point directly to the value, you may point to another pointer. Now it's weird, right? People may ask, why do I need a pointer or pointer? Think about a situation where you actually want to manage a very complicated structure of data in your programs. It goes like this. I may have a pointer. I point to an array, and then for each element of the array I may have the address of another array, for example. Okay, some is longer than the other, some is shorter, and so on and so forth. Some may be empty too, so it depends on you, right? Now if you have the organizations of your data this way, then obviously what you are talking about is you need this pointer or pointer, because this one is an array of pointer, right? It's so obvious. So here we go, we have some other example that demonstrate the pointer or pointer. You can read it. One more thing you have in the language is a reference. Now think about reference as a way to bind two things together. Okay, let's say you have A and B. Okay, A is a variable that store the data, the real data, and B is a reference, and that B, when you assign a reference to A, which means you do the binding job, you bind B to A. So whatever you do with B, A changes accordingly, and whatever you do with A, you will see the effect when you read B. Okay, so that is the top of the iceberg. The bottom is pointer. Okay, think about it this way. The reference will be implemented by a pointer, and one rule you have here is that when you declare a reference, that reference cannot be changed. Okay, so reference is similar to the constant pointer. Alright, and well, I know it's a little bit weird to you at first, but you can get it when I come into the demonstration, or you may want to put up some questions. Then I'm okay with you to discuss this matter on the class, because it's so important to you to understand what's happening behind the scenes. Okay, here I have some note on pointer and reference. I guess you can read it, so let me talk about it on the class later. Now as you learn about pointer, you can declare data now dynamically. You can allocate your data as you need it. Okay, remember last time you declared an array and the sign of that array must be fixed. Now no more. You can depends on what sign you need for the data, you can declare accordingly. Okay, so we are talking about the dynamic memory. Here are some essential informations. I'm not going to jump too much detail. Let's save it for the class. Alright, now you see I have a pointer, and I can use the new operator in order to allocate data. Now if you use new and the data type here, let's say I will allocate one single memory for that data. okay? But you can also allocate a sequence of data. Let's say new data, and here is the sign of your data inside the bracket. So it's similar to an array, right? It's like you allocate an array of data and then you assign the beginning address back to the pointer. Okay, that's how it's works. When you are done with the memory, it is a good practice for you to remove it from the memory. So restore the memory to let the program use that memory for good, right? So you can use the delete pointer here. Okay, you can also use the delete pointer here, but the difference between them is this bracket. The first one say release one element, the second one say release an array of data. Okay, so be careful with this one. I warn you will encounter some strange error when you run the program, and if the pointer you put in this delete is incorrect, then you may see your program crash right away. That's crazy. Okay, so far we discussed about structured data type that include array, structure, pointer, and how to manage the memory. So what I want you to get from this lecture is try to think simply. Okay, don't make things more complicated than it should be. Think about pointer is nothing but an address. That's it. Okay, how you can assign the address of memory to a pointer, how you can move your pointer, how you can access the data where the pointer point to. That are some key note you need to take from this lecture, and some more detail will be demonstrated later, but I want you to take note whatever still confuse you right now, because it will help you in the long run, and I will try to explain every of your concern better on the class. Okay.